On August 5, 2026, something slammed into the moon. Not a meteor, not a natural object, a rocket, a piece of hardware built by human hands, launched from Earth and left to drift through space for over a year and a half. It hit at 5,400 miles per hour. The impact blasted a crater roughly 89 feet wide into the lunar surface. Debris shot nearly 100 kilometers into the sky, and most people never heard about it. But here is what makes this story extraordinary. This rocket wasn't supposed to hit the moon. Nobody planned it. Nobody programmed it. A piece of space junk found its own way back, and scientists watched it happen. So where did it come from? What exactly happened when it hit? And what does it mean for everything we are planning to put on the moon next? On January 15, 2025, a SpaceX Falcon 9 rocket lifted off from Kennedy Space Center in Florida. Its job was to deliver 2 lunar landers into space. Firefly Aerospace Blue Ghost, a NASA-funded mission that would go on to spend 14 days operating on the lunar surface, and iSpace's Hakuto R Resilience, a Japanese private mission headed for the moon. The rocket did its job. It deployed both spacecraft successfully. And then the Falcon 9 upper stage, the second stage that had done the heavy lifting, was left behind. This is standard procedure. Once a rocket's upper stage delivers its payload, it has no more fuel to perform a controlled re-entry into Earth's atmosphere. It has no more mission. It is, in the language of the space industry, space junk. But this particular piece of space junk was in an unusual situation. It had traveled so far from Earth into a region where the gravitational pull of the moon, Earth, and the sun constantly compete, that it could not simply fall back into Earth's atmosphere and burn up. It was too far out, too influenced by competing gravitational forces. For 18 months, it drifted. Solar pressure pushed it, gravity pulled it, and slowly, invisibly, the laws of orbital mechanics wrote its fate. Let's walk through exactly what happened, step by step. Step 1. The drift after deployment. The Falcon 9 upper stage entered a chaotic region of space where no single gravitational body dominates. In this region, solar radiation pressure, the gentle but constant push of sunlight on the rocket's surface, begins to matter. Over months, this pressure, combined with the gravitational tugs of the Earth, Moon, and Sun, slowly altered the stage's trajectory. Independent astronomers tracking space objects detected this drift and began running projections. What they found was alarming. The trajectory was converging on the moon. Step 2. The identification. The object was catalogued as 2025-010D. It measured approximately 45 feet long and weighed around 4,000 kilograms, about 8,800 pounds. That is roughly the mass of a large SUV, traveling at over 1.5 miles per second. Independent analysts, including Bill Gray, who runs the Project Pluto asteroid tracking software, refined the trajectory calculations and published their findings. The object was going to hit the moon. The impact was predicted near Einstein crater on the lunar western limb. The predicted time, 0635. On August 5, 2026, NASA confirmed it. The scientific community prepared. Step 3. The impact. At 0635 U on August 5, 2026, it happened. The Falcon 9 upper stage hit the lunar surface at approximately 5,400 miles per hour, 8,700 kilometers per hour. At that speed, the kinetic energy released was enormous. The impact excavated a crater estimated at roughly 89 feet, about 27 meters, across and approximately 5 meters deep. Millions of kilograms of lunar soil and rock were blasted upward in a violent debris plume. The European Southern Observatory's Very Large Telescope in Chile, along with South Korea's Danuri Lunar Orbiter and NASA's Lunar Reconnaissance Orbiter, all observed the event. ESO confirmed the detection of sodium and lithium gas in the impact plume. Sodium from the lunar soil, lithium almost certainly from the rocket itself. The rocket was gone. In its place, a new crater on the moon, and a cloud of gas and debris that rose nearly 100 kilometers above the surface. Step 4. The scientific opportunity. What made this event remarkable was not just the impact itself. It was the fact that scientists knew it was coming. Most lunar impacts are discovered after the fact, when orbiters image new craters that weren't there before. This one was predictable. Scientists had weeks of lead time, which allowed them to deploy telescopes, orient orbiters, and observe the entire sequence in real time. The impact provided a rare opportunity to calibrate models of ejecta-plume behavior, the science of what happens when objects hit the lunar surface at high velocity. These models matter enormously for the future because every spacecraft, astronaut habitat, and piece of infrastructure placed on the moon is vulnerable to exactly this kind of impact. Here is where the science of this event reveals something genuinely important. The Falcon 9 upper stage ended up on a lunar impact trajectory because of a combination of factors that are, frankly, difficult to prevent. Once a rocket stage is deployed in deep space, with no fuel for a controlled disposal, it becomes subject to the complex three-body gravitational dynamics of the Earth-Moon-Sun system. In this environment, even tiny forces matter over long timescales. Solar radiation pressure, the force exerted by photons of sunlight hitting the rocket's surface, is usually negligible for large objects. But over 18 months, acting continuously, it can meaningfully alter a trajectory. This is why predicting the long-term fate of deep space debris is so difficult. The forces involved are small, the timescales are long, and the interactions between them are chaotic in the mathematical sense. Tiny changes in initial conditions lead to dramatically different outcomes. The impact itself produced a crater consistent with the predictions. What was slightly surprising was the detection of lithium in the ejecta plume. Lithium is not a natural component of lunar soil in significant quantities. Its presence strongly suggested that it came from the rocket's batteries. Batteries, hardware that survived the initial impact well enough to contribute its chemical signature to the debris cloud before being vaporized. But here is the twist in this story that changes the way you think about it. This was not the first time a rocket stage hit the moon unintentionally. In 2022, a rocket body, initially misidentified, then traced through a series of orbital analyses, struck the moon and created not one crater but two. The double crater was unusual and suggested the object had a non-standard mass distribution, possibly indicating an additional mass at one end, perhaps a motor or secondary hardware that was not publicly disclosed. That 2022 object was never definitively identified. China denied it was theirs. Other candidates were ruled out. The moon gained a double crater from an object whose owner remains officially unknown. And beyond that, there is the deeper twist. As we put more hardware in space, the rate of uncontrolled impacts will increase. There are currently roughly 35,000 tracked objects in Earth orbit and beyond. Not all of them will stay where they are. Some, like 2025-01D, will find their way to the moon. Project Pluto, if NASA and international partners are serious about building permanent infrastructure on the lunar surface, habitats, power stations, communication networks, then every uncontrolled object in deep space is in a sense a potential projectile. So here is where things stand after August 5, 2026. The Falcon 9 upper stage no longer exists as a physical object. It was traveling too fast, carrying too much kinetic energy to survive impact in any recognizable form. The hardware was vaporized, scattered, and partly absorbed into the lunar regolith at the moment of collision. What remains is a crater near Einstein crater on the moon's western limb, a new permanent feature of the lunar surface, created not by a natural process, but by human activity. And it joins a growing list. The Apollo program left hardware on the moon deliberately. Crash landing probes have created impact sites. The 2022 mystery object created its double crater. Now the Falcon 9 stage has added to the tally. The impact also raised a serious question for the future. If NASA makes good on its plans for a permanent human presence on the lunar surface, how does it protect that infrastructure from space debris? Lunar ejecta from an 89-foot crater can travel nearly 1,000 kilometers across the surface. A human habitat in the wrong place at the wrong time would face a debris field at lethal velocities. Project Pluto. Here's the thought that should stay with you. A rocket launched from Earth in January 2025 spent 18 months drifting through the gravitational chaos of deep space. Pushed by sunlight, pulled by the moon and Earth and sun, until the mathematics of orbital mechanics delivered it at 5,400 miles per hour to a specific point on the lunar surface. No one guided it there. No one programmed that destination. It arrived because that is where the laws of physics sent it. We are now at a point in history where humanity's discarded hardware is becoming part of the geological record of another world. The moon's craters are no longer only natural. Some of them were made by us, accidentally, unavoidably, as a side effect of our reach into space. The question is not whether this will happen again. It will. The question is whether we will be prepared. With the tracking systems, the impact prediction tools, and the infrastructure shielding, to make sure that the next time something finds its way back, it doesn't find a human being in its path. The rocket is gone. The crater will remain for billions of years. And somewhere in the records of the European Southern Observatory, there is a chemical signature, a trace of lithium from a battery. That is the last evidence that something built by human hands once traveled that far and hit that hard.